In the types of collision, the first is called based on motion, and based on motion, we have two types of collision. So we have head-on collision, and second is the oblique collision. So now, what is head-on collision? So let's say we have two spherical bodies, and let's say both are moving along this direction. Now, for spherical bodies or for bodies with circular cross section, if they hit each other, let's say these are two spheres. If they will hit each other, then what will be the line of impact? So we can see clearly that any line which passes through the center of both these spheres, C1 and C2, will be the direction of normal direction, and so that will be the line of impact. So we call this as line of impact. And for bodies with, for spherical bodies, or you can say circular bodies, the line of impact also becomes common normal. Because at the point of impact, what is the point of impact? The point of impact is the point at which they hit, okay, so where they will make the contact during collision. So definitely at the point of impact, we call this point as point of. So this is the point of impact. And now, if you draw the direction of force at the point of impact, it automatically becomes the common normal. And we know that the action reaction force will act in this direction. The impulse will act in this direction. And that is why we call this reaction as line of impact or common normal. And if you draw perpendicular at the point of impact, so we call this as common tangent. So what we need to realize that whenever there is a motion of two particles, whenever there is a collision of two bodies, if the line of motion of every body, every particle, each body can say, just before the collision lies along the line of impact. So the line of motion of every particle colliding, every body colliding, if it coincides with the line of impact, we say head-on collision of one dimension. So V1, V2, you can see V1, V2 is also parallel to this white line, which is the line of impact, and therefore we call this as head-on. So in head-on collision, the motion occurs along a line. So that's why we call it one-dimensional collision. So in head-on collision, the impact will happen along a line, and therefore we call it one-dimensional collision. So that is the essence of head-on collision. That the line of motion. So if you want to put in words, Okay. So now this is the hidden collision. So what is the oblique collision? So in oblique collision, we have, let's say we have a line, and imagine one of the body is at rest, it's not moving at all, and the other mass is moving along this direction. Okay. So now this is moving, and when they will hit, so this is the line of motion of the mass one. Let's call it. The other one is at rest, so there is no line of motion. Now, what we can realize clearly that at the moment the collision will be made, now this is the point of impact. Now you can see the point of impact. It has changed now. And therefore, if you think of the line of impact, now if you think of the line of impact, it will be the line joining their centers, and therefore the line of impact the line of impact, and you can see the line of motion of the one of the particle, not necessarily both. If even one particle is not following the line of impact, we call it oblique. This is the line of motion. So we say that if the line of motion of any mass do not coincide with the line of impact, then the motion will be called, I mean, the collision will be called oblique collision. This is common normal, and the common tangent is somewhat like this. And the way to solve questions like this is resolve the velocity along the common normal and common tangent. And then what next? So once you resolve the velocity along the common normal, you can treat that component as the one-dimensional collision. So you can just write the conjugation momentum along that common normal direction and then solve, because the common tangent is not the direction in which the impact will have any effect. So you can say impulsive force along this common tangent is zero. You can say J is zero. There is no impulse. So all the impulse will act along the common normal, and therefore the momentum exchange between the masses will take place only along this common normal. Or you can say the component of momentum which will be affected is the component along the common normal. Or you can say the velocity of the object will be only affected in the direction of impact. So once you know the velocity of a particle along the common normal by resolving it, you can treat that as a only velocity and then solve the question similar to the question of one dimension. That is the whole idea about oblique collision. In JE syllabus, all of the oblique collision will be such in which one of the mass will be at rest and other mass will be moving. So the way I have shown the example will be the only example you will face. Okay. So the next was based on energy. As I said, based on energy, we have three classification. The first one is called perfectly elastic. Second is you can say either elastic or inelastic. Inelastic. So let's see what goes in those discussions. So let's say we have okay, we can take a example of a block. Imagine both are moving along the x-axis towards the right. So I'm taking the case of one dimension, and the velocity of the first mass is u1, and second mass is so now tell me to collide. Okay, when these two masses will collide, when m1 will hit the m2. So what should be the velocity relation for making this collision possible?
U1 should be greater than
That's the obvious thing. The u1 is more than u2. Then only we can think of collision. So the u1 will approach u2 or will go away from u2. So the answer is it is going to approach u2. So now when they are about to hit, when they're about to hit, and after this hitting will take place, some deformation will occur. So both will deform each other, and so eventually, okay, let me make this one. What will happen is this: the two will deform. So a part will be like compressed, and now the shape is deformed shape. So from the moment you are about to hit the block when they are about to hit, and when they hit and get compressed. So this is the, let's say this is the situation called maximum deformation. And maximum deformation is a state at which no matter what type of collision you may call it, both will move with same velocity. So let's call it V. So we don't know what is V, but whatever it is, it will must be same for both. And now from the concept of conservation of momentum, this V turns out to be nothing but the UC. Why? Because we know that any internal force cannot change the velocity of center of mass. And when both will have the same velocity V, then it must be equal to the center mass velocity. If you don't believe what I'm saying, let's do it mathematically. So from the concept of conservation momentum, what we can write? M1 U1 plus M2 U2 equals to M1 plus M2 into V. And V turns out to be how much? But by definition, this is UC. So momentum conservation and velocity of center mass is same thing actually. Also, if you try to find the VCM at this instant, the other perspective, what is VCM formula? M1V plus M2V. If both are moving with the same velocity, it turns out to be whenever a system having any number of particles, and if they move with same velocity, then that velocity will be nothing but the center mass velocity. And because center mass velocity is not changing, so this must be equal to UC. This is the other perspective of thinking. Anyone who understood this, what I said? So what I'm saying is, if you try to calculate the velocity of center mass, you get the answer same as V. And because we know that in a process of collision, the velocity of center mass will be unaffected. So whatever was the initial value, that will remain intact. So VCM is same as UCM, and so is the answer. So conservation of momentum is a direct consequence of center mass velocity. So these are two aspects of thinking. You can think either way. But after every deformation, the next step is they try to push each other and try to go away, because the compression will create the extra force, and then eventually they will separate. And because the impulsive force is acting on the M1 left and M2 right, so because the force acting on M1 is left and M2 is right, so the final velocity of M1 is bound to be less than V, but the velocity of M2 is bound to be more than V. And therefore, the V2 is bound to be more than V1, because you start with the same velocity V here, and while going forward in the process of restoration, the M1 will be further slowed down by the impulsive force, whereas M2 will be speed up. So eventually, M2 will be moving faster than M1, and this situation is called velocity of separation. So velocity of separation we can write as V2 minus V1, because V2 is more than V1. But if you look at the velocity of approach, the way they are trying to approach, we can easily say it is U1 minus U, because U1 is bigger than U2. We are writing values. So now there are three events that we have discussed. When you start, I mean, you're about to collide, then you hit and deform, and then you restore and go back. So if we analyze this further, so let's take some example again. So let's say they're about to hit, and we are assuming this to be identical so that they hit at a point which makes uh, head-on collision. So this is called just before collision situation. And then next is what the maximum deformed state. So they are like uh, deformed after collision. And at this state, they will move with a common velocity, which is equal to UCM, as discussed above. And when they will hit, then the impulse on M1 will be left and M2 will be right. So the impulsive force which acts in the duration from here to here, so this impulse we call impulse of deformation, and we denote by JD. So JD is called the impulse of deformation. This is the deformation force acting. So the force acting in the duration from the moment you make the impact until you get compressed, we called impulse of deformation, and then again you recover. So when you recover back, you may or may not be in the perfect shape. So when you recover, when you separate away, it will not guarantee that you will be in the perfect shape. So you may carry forward some deformation as well. So it is possible that some deformation remains permanent for both of them. And now they will move with velocity v1 and v2. And the impulse acting in the recovery mode, during the recovery mode, we call impulse of recovery, or it is also called restitution. So the restitution is the word for recovery actually. And the symbol we write for JR. So R for, you can say, restitution or recovery. So imagine that if deformation created during the impulse of deformation, okay, so we can also call this duration as duration of deformation, and we can call this as duration of recovery. So in the duration of a deformation and the duration of recovery, the impulsive force will be given two different names. One we call deformation, other we call recovery. So from the duration of deformation, it will get compressed. So deformation will keep on growing actually. and the duration of recovery, the deformation will be regained. So in a way, you're trying to go back to your original shape. But what I'm saying is that the regain is not always feasible to the extent of 100%. So imagine if you can recover 100% completely, and there is no deformation left at the end of this entire duration, which we call duration of impact. So from here to here is called duration of impact. Every duration of impact we can divide into two parts. What I'm saying is that at the end of duration of impact, if some deformations are left for individual masses, so we call it elastic or inelastic. And if you recover 100%, we call it perfectly elastic. And if you maintain the this state, and if there is no recovery state at all, let's say your journey ends here, so you get compressed, and that is maintained throughout, so you never recover at all. So if the body compresses and never returns, you can see body is moving, but it will never recover. And if that happens, we say that it is perfectly inelastic. So the word inelastic means there is no question of recovery. Perfectly inelastic means no question of recovery. But when I say elastic or inelastic, which means a partial recovery is feasible, and when I say perfectly elastic, then full recovery is possible. So based on this recovery, we have given a name: perfectly elastic or inelastic or perfectly inelastic. So all has this to do with the energy. Now, what deformation refers to? So deformation refers to the fact that some part of kinetic energy has been converted into potential, and that is still present in the system. So there is a loss of kinetic energy, but there is no loss of total energy. So if you take care of every energy which you think of, then it is constant. But if you only consider the kinetic part of the system, then definitely every conversion into potential will be a significant loss. So some loss will be due to heat and sound also. The impact creates sound, but those losses are always insignificant compared to the potential loss. So the a chunk of energy which was kinetic will become potential, but some potential will be some kinetic will be also remains the same. Now from the observation you can see something. So in case of perfectly elastic collision, what is the final velocity? In case of perfectly elastic collision, can you tell me what is the final velocity?
Same.
No, what is the value? It is same as UCM. So you can see that the final velocity is how much? UCM, right? Because that is the end of the journey. So in case of perfectly elastic collision, the body will continue to move with the velocity of center mass. Why this so? So it will continue to move so because we cannot take away the center mass velocity. That is the velocity which is meant for conserving the momentum part. So VCM is maintained because we know that in any collision we cannot alter the VCM. So when they do not move relatively, or when you have a system, listen very carefully what I'm saying. When you have a system in which every particle moves with same velocity, then it must be the center mass. And that is proven here, as you can see here. So if every particle moves with same velocity, then the only velocity for which this is possible is the velocity of center mass. Understood? So VCM is the velocity if you see that every particle or every mass of the system having equal velocity, then that is bound to be VCM or UCM. So in the case of perfectly inelastic collision, your journey ends here, right? This is the end of the journey. So there is no recovery phase at all. And therefore you continue move with UCM direction. So you will continue moving with UCM. Understood? Oh. So that is the deeper theoretical analysis about collision. Now what we have to read next is called Newton's law of collision. So what is Newton's law of collision? So this is the experimental law given by Newton. So what this law says that, so it was a very common observation for Newton that he started dropping a ball on a hard surface. He dropped something from a given height or certain height. So he recorded the height definitely. And after hitting, it also bounced back, but to a slightly lower height. Then again it fell down. Let me draw it separately. But again he bounced back to a lesser height. Now, a very striking feature which he observed that if you draw from drop from certain height and it goes to certain height back to a certain height, h then h is h dash and so on, it will keep on bouncing like this. So what he realized that no matter what a capital H you choose to drop and what a small h you get afterwards, the ratio of these two height or h dash by h dash or maybe h double dash by h dash and so on. So experimentally it was found that all values are constant. So this never changes. It means no matter from which height you drop, the rise is always a constant. So it means the ratio must be representing some characteristic of colliding surfaces. So here the ball and the floor are two surfaces which makes the collision. And they have some inherent property that you will hit me this speed, I will throw you back by a fraction of that speed. And that fraction will be always a fixed quantity no matter what. So that is the postulate of Newton's law of collision, which says that the relative velocity of separation to the relative velocity of approach between any two surfaces remains constant independent of colliding speed. So that is the basic statement of this law. So when you're about to hit the surface, so you have some speed u, and other surface is fixed, so it's not moving. And when you bounce back, if you have a speed, let's say v, so u depends on capital H, because we know if you drop something from height h, it will have speed under root 2 gh, and the v will decide the height at which you can go up to. That's called the maximum height formula. V is equal to 2g. So what Newton is saying that for any pair of surfaces, for any pair of surfaces, for any pair of surfaces, the relative velocity of separation. Now, separation means how fast you separate from each other, how fast you grow the gap. So the relative velocity of separation to the relative velocity of approach remains constant and independent of speed of colliding bodies. It really doesn't matter what speed you hit and what speed you go, the ratio will be same thing. So the faster you hit, the slower it will hit, slower it will go back. The idea is the speed with which you hit, so the rate at which you are separating after collision and the way you are approaching, that ratio will bear a constant value. That constant value we call coefficient of restitution, which is a fraction between 0 to 1. So this is the experimental law given by Newton, and according to this law, the relative, the ratio, the ratio of relative velocity of separation to the relative velocity of approach. So this is the experimental law given by Newton, and according to this law, the ratio of relative velocity of separation to the relative velocity of approach remains constant and independent of a velocity of colliding bodies. So it's the other way around. So the speed with which you will return back, or you will recede, or you will separate, that is already predetermined by the coefficient of restitution. So this constant value is called coefficient of restitution. So here we have only one surface as a moving surface, the other surface is like a fixed surface. So the floor will act as a fixed surface, but that is also surface. But in general, if you take the example that I took it earlier, so this is just before collision. and we'll take the just after situation, not much long time after. So just after collision, then the definition of E, which we call coefficient of restitution, will be the ratio of separation velocity. So they will separate at v2 minus v1 because v2 is bigger than v1, and the approach is 1 minus 2 because 1 is bigger than 2. And this number must be positive number. So the worst it can go is from 0 to 1. So 0 is for perfectly elastic. And 1 we call for the perfectly elastic. And other value from 0 to 1 fraction is for a general collision case. These are two extreme conditions. So E0 means V2 and V1 are same. That's the idea. You can easily understand if I make V2 equals to V1, then the answer will be 0. And the perfectly elastic means the separation and approach will be always same. So U1 will change to U2 and V1 will change, like U1 will change to V1, U2 will change to V2. But the ratio of the difference will be same. So that is the beauty of the perfectly elastic collision. So you can find the separation equals to approach. So it means if you hit by the speed u, you will go back by u only because that's going to be same. So in this case, it's very easy. If I try to write here, if this is the surface 2, and if the ball will represent the surface 1, this is the surface 1. So what is the velocity of separation? Can you tell me here? So this is like a fixed surface. So the velocity of separation is how much? At what rate these two will go away from each other? No idea.
1.
So it's v. And what is the approach? It's u. So v will be equal to e times. So for two surface in which one is fixed, we only look for the other surface at what rate it is approaching and receding. That's it. What we look for. So let's take some more. So in a game of carom, this is in a game of carom. The edges are like fixed surface. If I draw a point, and let's say this point is moving towards this line. Now, it may bounce non-perfectly, so it's not necessary that it will bounce back perfectly. if I say E is the coefficient of restitution, so if you draw perpendicular at the point of impact, so this is the U is the speed, and after hitting the edge, it will bounce back and it will have two components, one right and another up. So if I call up as Vy and horizontal as Vx, so what you have given is the theta and u. So this will be u sine theta. This is also theta because of this. And this angle we don't know, let's call it phi as of now. So what we can talk about the E definition, like how we can write E here. Tell me. Let's say Vy, Vx are the velocity just after collision, but that will remain constant as we know. Imagine all surfaces are smooth.
Sir, that theta is equal to phi.
Theta equals to,
Phi.
but how can you say that?
Sir, because that angle of incidence is equal to angle of action.
But that is only true for the perfectly elastic collision. But I am saying here the coefficient of restitution is E, which means it is not perfectly elastic. It's somewhere between 0 and 1. So that assumption will not be true. So how we learn the definition of E? What is definition of E? Just try to apply the definition. So you have to think of separation and approach. So tell me at what rate you are trying to approach the edge, the surface. Hmm? Tell me guys, this is not so difficult.
Sir, can you repeat? I didn't.
What I'm saying is simple thing. You have to think of the coin is approaching the surface and the rate at which it is going away from the surface. So which component will take you closer to the surface or away from the
U cos
surface?
theta.
The vertical component, right? The y component.
Yes.
So by definition, what is E? The separation upon approach. What is separation here? At what rate the coin is going away? Hmm? No idea. So you have to look at this diagram carefully and answer it. So what is the velocity of separation? And I think we have done this in relative motion as well. So you should be able to answer at least this separation and approach problem. Or you don't understand the meaning of separation and approach? Is it so difficult to understand? Separation means going away, approach means coming closer. So when I say velocity of approach, So look at the surface which you hit. So the two surfaces which will collide, at what rate they are coming close? That's the only answer. At what rate they come closer and go away. That's it. So is it so difficult to answer? Hmm? Tell me. Hello, 1 2 3, 1 2 3. What happened? Not able to recognize the approach and separation? Anyone?
Sir, is it U cos theta by V bar?
It is Vy by U cos theta. You write first separation, then approach.
Okay.
Separation is the final event, approach is the initial event, and the initial event will write in the denominator and finally in the numerator. So this gives you the idea that Vy must equal to how much?
EU cos theta.
And if you understand the concept of impact, which you should, then you will realize that impact is only possible in this direction, and therefore the direction which is perpendicular to the impact, the velocity will be unaffected. So this impact or this impulse cannot change this value. So Vx will remain what it was, and therefore the angle phi is determinate. We can calculate this value. So I can add tan phi equals to how much? So you will realize that this is Vx upon Vy. And by the way, what is Vx? So we just realized it is u sin theta. And what is Vy? So it is u cos theta. And as already understood that these things will remain independent of the velocity. So the phi is a already the fixed quantity. Once you fix the theta and once we have the fixed value of E, no matter how hard you hit or how slow you hit, the angle of reflection and the angle of incidence will have this beautiful relation, and it has nothing to do with the speed. So these are predetermined things. So it is other way around that the velocity relation will depend on E, not the vice versa. So the angle relation will depend on E, not the vice versa. So E determines various relation in advance. So this we call you can say Snell's law of collision kind of thing. So here we have something slightly different. So it's a tan of angle of phi is tan of angle of theta upon E, because E is less than 1. Therefore, phi will be more than theta. So the only possibility is either phi will be more than or equals to theta. That is the only reason possible. So when they will be equal? When E is 1. So equality will hold and of course we assume all surfaces are smooth. So we are not taking frictional effect also. So you can also understand why. Whenever you hit it, your speed will slow down because you become E times value. So Y component will be smaller than the initial value. x component is the same as the original value, so therefore phi will always increase because the resultant will shift towards Vx. Therefore, the angle of a deflection, or you can say reflection, is bound to be more than or equals to angle of incidence, and the equality will hold when it is perfectly elastic collision. For other case, this is the answer. So now this kind of information or this kind of formula will have a far-reaching consequence. So once you know the theta and once you know the phi, you can easily find the value of E. Like if you can see the deflection, you can directly calculate the E value. So let's say if you have an inclined plane and if you drop a ball, just click the photograph of the reflection direction of ball, and from that graph or photograph, you can draw the angle and you can actually find the E value. So that's not very difficult. So in most of the sports across the world, for let's say Olympic game, we have a football, we have a badminton racket or basketball. So anything which can reflect. So the international authority, or you can say Olympic Association, they give a protocol that what kind of E value is acceptable by various manufacturer of various sport goods. So whoever is manufacturing, let's say Adidas or Nike, which also manufactures the sports goods, let's say you manufacture football, someone is manufacturing cricket ball or whatever. So all these international authorities, they put a condition that what kind of E value will be accepted. And generally 0.84 to 0.9 is the accepted value. Beyond 9 is also not accepted. Okay, anyway, so these things are very important in also real life scenario. So the coefficient of restitution is having worldwide consequence in the entire gaming industry, you can say, or you can say basically the gaming manufacturing industry. So also when we design the video game, let's say if you're designing some sort of game in which we are having the Angry Birds game and you see some reflection happening. So in the coding, they also put the value of E to determine that what kind of reflection they expect. So all these things are done mathematically, and most of the formula of physics is when you really become a very good programmer in a very big company, let's say mostly gaming company, then your idea of physics and math will be at your rescue. So the best one are good with physics also. Anyway, so let's see something more. So imagine a ball is dropped from certain height. So we don't know what is the height, and that's not required as well. But after hitting the ramp or the plane, it bounces back exactly horizontal. So you drop it from horizontal vertical direction, but it deflects in this direction after hitting. And of course, it move in a parabolic path afterwards, but just after this is the path. So the question is, what is the coefficient of restitution for this surface? What is E? Anyone there? I hope I am audible to all of you guys.
Yes.
So tell me the value of E of these two surfaces. So what is the E value defined for the ball and the this ramp?
Is it one?
Pardon?
One.
No, it is definitely not one. So what is the angle of incidence? What is the angle of incidence? Tell me, guys. Am I audible?
Yes.
So what is the angle of incidence? Tell me. Okay. You can drop a normal here. And if you drop a normal, then you can find the angle of incidence. This will be theta. This will be 90 minus. And therefore, by definition, E is given as you can say tan of angle of reflection is equal to tan of angle of incidence upon E. So E becomes tan square root. Okay. So it's a very simple problem that which only demands the definition of E and you will get the answer. So this formula is very, very important and crucial for you guys. So tan of angle of reflection is, so for any fixed surface we can apply. So I hope you remember this. Next. The next is very nice. Let's say I am the co-creator of a game called Round Carrom, and I have dictated the rules of this game. So if you want to play this new game called Round Carrom, so the carrom board having the round edges, and then there are some pockets for sure. So these are some pockets. Uh, so let me create some pockets. Or let's say this is a coin, okay, and the edges are round, like a circular edges. So what we do is, okay, or this pockets are like only drawn. It's not a physical pocket; they are just drawn. And now I throw this. Sorry, I hit this towards one of the edge in such a way that if you draw the normal here, which will definitely pass through the center of the circle, this angle is theta. And every time you hit it, the coefficient of restitution is found to be E. So the question is, the ball will bounce or reflect from there to here, and eventually I want that it should come back to here. So the question is, what theta we must choose so that after two reflection, it comes back to the same point. So that's the question. We have to find the theta in order to this entire thing comes back to the same thing. So you start from here and you come back to here. So this is the problem. So if your stacker will hit the same point, you will get some points or maybe some rewards. So the question is, what is theta? So if you want to try, you can try as also, not an issue. So anyone interested in solving this question? Yes or no? Tell me.
Yes,
No. Okay, fine. As okay.
sir. Yeah.
You want to solve?
Yes.
Okay. So now I have given the enough hint what to do. So basically, this is a mathematical problem. So you need to think more of course, physics is a small part, which is a Newton's law of reflection, or Snell's law, you can say. Snell's law of collision, and a bit of trigonometry to get the right answer. Then, guys,
No.
so look at this. How to solve this question? So to solve this question, you need to understand something about mathematics. So this angle will be same theta because this is the radius. But after the first collision, of course, angle will change. So if I call this angle as alpha, then this is also alpha. But again, after the collision, angle will change. If I call this beta, this is also beta. And now we can use the property of triangle. What we can write is twice of theta plus alpha plus beta must be equals to 180 degree. and therefore the theta plus alpha plus beta is 90 degrees. So you can say alpha plus beta. I'm going to take theta on the other side. So that is what I'm trying to calculate. So now what we do is called taking tan both sides. Taking tan both sides of equation 1. So tan of alpha plus equals to tan of 90 minus theta. This is tan alpha plus tan beta, and this is cot theta. Sorry, 1 minus tan for tan beta. This is cot theta. And now tan alpha we can write. So you can see from Newton's law, this law. So tan alpha must be tan theta by E. And tan beta must be tan alpha by E, which eventually becomes tan theta by E square. And so the only matter is just substitute the value. So tan alpha is by E plus tan theta by E square, and 1 minus tan square theta, yeah, by E cube. And this is cot theta. So if you multiply, cross multiply, you get the answer. Just you can take the cross multiply and rearrange, you get the answer. So I don't have space, so I'm leaving it here. So I hope this is clear to all of you. Is this clear, guys?
Yes.
So in this chapter, the most important skill is writing the definition of E properties. Many times, if you know how to conserve momentum, but if you don't know how to write E, mostly you will not get the right answer. So understanding the line of impact and so many things is needed. So let's take some more example. So in case of collision of lighter object with something very heavy, the heavier object will never buzz. So in a way, we assume that when a very light hits a very heavy object, the momentum of the heavier object is assumed to be constant, and so its velocity, if any. So let's say if we talk about the game of cricket or a game of football. So when a footballer is hitting the football, the foot of the footballer is a moving object which hits the football, which is also a moving object, or maybe a stationary object, or vice versa. So what we understand is that the foot is relatively very heavy compared to football, and therefore the collision between the two can be considered in a way that football cannot change the momentum of the foot, but foot can change the momentum of football. So you can take the example of cricket in which the bat is really heavier compared to the ball. So when the ball is hitting the bat, then the ball most probably will not change the momentum of the bat. Of course, if it's a fast bowler, then it will change that drastically. But in normal case, it will not. And we have taken the example of floor and the ball. So when you hit a floor or a ceiling or wall, so these all are examples in which the momentum will only, I mean, the momentum change will only be occurring with the lighter object, not with the heavier object. These are the series of problems which is only solved with the help of definition of E. We never conserve momentum because momentum should not be conserved when we have very heavy and very light object. So for all those questions in which the collision happens between very light and very heavy, the momentum should not be conserved at all. Only the definition of E will be suffice. Okay. So we can say collision of very light with very heavy object. So in such case, we don't conserve momentum, rather we only write the definition of E, and that will be sufficient. So let's say there is a wall. Okay, so this is a wall. And now imagine this wall is translating with a speed v. So this may be the example of truck. Okay, so you can think a truck, and in fact, I can create a truck only. That will be better visualization. So let's create a fancy truck, a truck with all decoration. Okay, so let's do this. You can think this as truck, and let's say truck is moving with its own velocity. Let's call it v. And don't try to mention. Okay, so now the question is, if you throw a ball, so that is what we do. So you may throw at some angle. I'm hitting it normally so that it's a head-on collision. So if the line of impact and the line of motion will coincide as we discussed earlier, so we call it head-on collision. And the coefficient of restitution is E. So we believe that such collision will never change the momentum of the truck. So truck is really heavy object, so we can understand also this is meaningful. So now how to solve question like this? So the ball will most probably, if the ball is really if V is really smaller than U, then in most of the case the ball will bounce back. So let's say the ball reflects or bounces back after hitting with a speed, let's say small, so let's say capital. So I want to know what is the value of small v, because capital V is given, which is like a velocity of truck or a wall. So we can say that the definition of E is the velocity of separation. So can you tell me what is the separation here? And separation must be looked for the surface, not for the truck. So what is the separation? Tell me. What is the velocity of separation? Anyone?
V.
No.
Okay, it's
So you guys have no sense
so V
about
plus
the
V.
relative motion. Yeah, that's V plus V. And what is the approach?
U.
No.
This is greater.
U is the velocity of ball, but that is not the velocity of approach.
So then V minus U.
No. So when you will approach, that's common sense. I mean that you have to apply common sense, which you are totally missing here. The ball will hit the surface only when you move. The ball is moving faster than the truck. Then only it can come closer, right? It must be U minus V. So you're not understanding the meaning of approach and separation. And that's a very pathetic thing. I mean, this is not what I expected after teaching rigorously the kinematics. The idea of separation and approach should be very clear. You go back to the chapter of relative motion, try to understand this chapter again. So you need to understand that at what rate the surface is coming closer, and to come closer, what should be the criteria? That's common sense. So I know that the U must be faster than V, and because both are in the same direction, so it's a U minus V. So you're trying to come closer to truck by U speed, and truck is going away with V speed. So what is the net velocity of approach? It's U minus V. Okay. And now this solves the question. So V plus capital V equals to EU minus. So the small v becomes, and this is again a very, very interesting and very important relation. So if I ask you, find the condition for bouncing back. So for what condition the ball will bounce back? Tell me. So what is the mathematical condition for which the ball will bounce back? No idea. So because when I was solving this question, I assumed that it is bouncing back and I got the answer. So my answer must be positive. Then only what I'm assuming is correct. The condition is V must be positive. Then it will bounce back. And this implies that EU minus, which implies that the truck velocity, the value V should be less than. So if truck is moving with a speed less than this value on the right hand side, which is EU upon 1 plus C, then only it will bounce back. So imagine what if, so no bouncing back condition, or you can say condition for, so what is the condition for moving the same direction? If you want to continue moving the same direction. So for that, the answer must be negative. Why?
It will
because
move in
I
opposite
because
direction.
I assume v as a bouncing value, but I don't want it, so it must be negative ones. So that will only change the sign. So v must be more than this value. But there is one more condition. It should be more than this value, but it must be less than u. Else it will never hit it. That's the problem. So the right way of saying the same is the value v should be more than u by 1 plus e, but still it should be less than uh, u. Why? Else it will never hit first. So the condition of hitting will be failed, right? So ball can hit the truck only when the ball is moving faster than you. So it gives you the range of values which you can take for truck. And what is the condition for stopping? So to stop the ball, you can just make v equals to 0. So there is no bouncing back, there is nothing. So v is 0. It simply becomes at rest. So this is the equality relation. And then this gives you something very interesting at for perfectly elastic condition collision. When e is 1, the v becomes u by. So now this is what is used by most of the international players or any football player, not international, any player. So if you want to stop the football which is coming towards you, you must move your foot at half of the speed which you can guess from your experience. And if you move your foot exactly at half of the speed backward, the football after hitting your foot will come to rest. So this is how they stop. Now, of course, they don't learn physics to do that, but they experience through training and okay practice. And also, if you don't, if you study physics, it does not mean that you can go in the field and can do that. So that understanding the value of u and then moving your foot backward at a speed at half of the value will stop the football. So now this question was asked by the Russian Olympiad. It's a very fairly simple question or answer, but it was very difficult that it is belonging to this chapter of collision. So you need to think about this is very difficult. It's a very old Russian Olympiad question, not today's. It's maybe a hundred-year old question. So now we have seen the three conditions of bouncing back, going in the same direction, and then stopping. So when it is stopped, so at what rate you must recede in the very beginning, so that the moment you hit, you come to rest. Questions which will only find based on the definition of coefficient of restitution. And I'm not conserving momentum so far. So you can see that there is no momentum conservation we are using at all. So the other variety of question which we generally solve without conserving the momentum. So this is a very nice problem having some name which I don't remember. So let's say we have a ground. And then what we have is called a large number of spheres. One sphere, and above this sphere we have another sphere. With a very small gap which you cannot see. And then we have another sphere. And in this way, we have infinite spheres. And now, what is the question meaning, or the way question is designed? that if this mass is capital M, this mass is small m, this mass is m dash and m double dash and so on. So every mass below is infinitely heavier than the mass above. M is much bigger than small m, but small m is much bigger than m dash. M dash is much bigger than m double dash and so on. So now the question is that every mass which you see is quite heavier than the mass above. Okay, and there is not one mass, there is infinite mass, so it may be 1100 whatever. And now this entire configuration, you can imagine that they all are joined with a thread, so the thread will create the gap, so it's like a one thread will hold the other will hold the other and so on. And it is like someone is holding at the top and then you release this thread, and this height is the initial height is, let's say, uh, small h. Now it is said that the coefficient of restitution everywhere is e. Between any two sphere it is e. Okay. So the question is, after it is dropped, after the entire system of spheres are dropped, find velocity of nth ball from bottom just after. So now, do you realize what is this question saying? So it is saying that you first drop. Now this gap will make sure something. So it will make sure that the first ball that will hit the bottom surface is the white ball. You can see the white ball. The lower most ball will hit the ground, and after hitting, what it will do? It will reflect back with what speed? What speed? So with what speed the white ball will reflect back? Okay, what is the speed with which it will hit the surface? That's the first question. Am I audible, guys? So tell me, what is the speed with which the white ball will hit the surface? What is this? If something will free fall from height h, what will be the speed?
Root
We don't know
2g
this. Root 2g what?
h.
So say it full, na? What is this root 2g?
Sir, my voice will be cracking, sir.
Okay. So the root 2g is the speed with which you hit the surface. Then what is the speed with which you bounce back? Tell me, with what speed the first sphere will bounce back? Tell me, guys, with what speed it will bounce back? E is the coefficient of restitution. No idea. Okay. Okay. So the speed with which the first sphere will bounce back is E times under root 2gh. So the first, now what we are also assuming is that every sphere is hit in the upward journey. So like when the below sphere will move upward, then it will hit the sphere above it. So it is like the first sphere will hit, will bounce back, and will hit the others. This will move upward, will hit the other, and here other, and this like this. So let's say first of all we'll take the first two spheres, one and two. So what we assume that if I assume v naught as under root 2 gh, because that is the velocity with which it will strike for the first time. So the ball will bounce back with velocity e v naught, and then the other will also is coming down with the speed v naught, because all will fall through same height, and now it will hit each other. So we know the definition of bouncing back condition. Like I mean, let's say it will bounce back. The first will go away with V2. Let's call V2. Why I'm saying V2? Because the first is so heavy that the velocity of the first will not change immediately. It will remain EV not even after hitting the upper ball, and this will continue moving with velocity EV naught, which was the value earlier. So this will remain EV naught, and now we write the definition of E. So what is the velocity of separation? No idea. So the velocity of separation is V2 minus EV naught. And what is the velocity of approach? 1 plus EV naught, because that's what we can see. So the V2 becomes EV naught plus E times 1 plus E into V naught. Okay. So I will prefer writing like this one. E, maybe I can take V naught now. So this will be, okay, 1 plus. So let's try to do this with 2 and 3. So how to do this 2 and 3? So 2 is going up with V2, but the 1 is coming, the 3 is coming down with V naught. And then it will hit back. So it will go back, let's say, by V3. And that will be sufficient to understand the pattern, because we just want to find the pattern. So we can add definition of E, separation upon approach, which is plus V times. Yeah. So we can add EV naught plus EV2 equals to, did I make some mistake? Yeah. Equals to V3 minus V2. So the V3 becomes EV naught plus 1 plus EV. Oh, that's better. So I should have stopped there only. EV naught is the first term, but second term is 1 plus EV2. This term and this term. So that's nice. Now let's substitute the V2 value so that we can see the pattern. And the V2 itself is how much? So this is a big term that we add on separately. So V3 equals to EV naught into EV naught plus now we need to find some pattern eventually. Hmm. So we can take common EV naught. What do we get? Yeah. Now that is the pattern. So if you follow the same rule, you can eventually at Vn equals to EV naught 1 plus E. So why n minus 1? Because you can see this is 3, this is 2. If this is n, this must be n minus 1. So it will stop there. So the nth part or nth ball will have velocity, and this is a geometric progression, and I hope you know the formula. I think this is the formula, right? You can correct me if I'm wrong. So for geometrical series A plus AR plus AR square dot A power n. So what is the summation? AR n plus 1 minus 1 by. I think this is the formula, right? If R is more than 1, then like this. So this is the number of terms actually. So R power number of terms, which is n plus 1 terms. It's R power n only. All right. So just check the formula. Is it the correct formula? The first summation. I'm just confused. This power n or n plus 1.
So,
Hmm?
so can you repeat? Sir?
I'm asking what is the like, just check the formula. Is it correct or not?
So what have you written on the power?
N plus 1.
Power.
N plus 1. Number of terms.
Sir, that plus one will not come.
Just let me confirm.
So it was only R square minus.
Hmm? Hmm.
Sir, that plus one will not come.
No, no, no. What you're saying is not correct. So here the n is the number of terms, right? So we okay, yeah, sorry. We have n terms only. So what I have written here is this is up to n minus 1. Then this is n. And if you add up to n, this is n plus 1. Because the number of terms will be n plus 1. No? If I write the a plus ar plus ar square plus dot 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 up to ar power n, Okay. So how many terms we have? Number of terms is how much? N plus
Okay,
the Sn formula becomes a into r powered number of terms minus 1 by. So this is what I applied here. So here we have n terms. So this is why we have n power minus 1 upon common ratio minus 1. So common ratio is 1 plus e minus 1 is e. This is cancelled out. So this is the answer. All right. So this is the question. Now these kind of questions are very very common in collision chapter. So if you solve the sheet or any standard textbook except the SC Verma, you get all these questions. In SC Verma, you will not find questions like this. The reason is they have only taken care of the basic conjugation problem, which are very fundamental and very, of course, important, but it does not covers all variety. It covers maybe 20% of the all variety. Anyway, so sequence problems are very important from the point of view of competition because it also involves the mathematical ability, and that's why it's important in a way. So let's do a small problem or maybe a simple problem. So this is called the Newton's Cradle. And it is readily available on the Amazon if you want to buy it. So imagine if we have a n identical pendulums and every pendulum is touching each other almost. So the gap is roughly zero. And of course, there is a small gap kept, which is negligible, and then we have many more. And then we have the last one. And all are identical in shape, but the coefficient of restitution in everyone is e. And this is n equals to 1, second pendulum, third, dot, 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 and this is the nth. So this is the nth pendulum. And there are many more in between which I am not drawing. Now the first pendulum is taken aside. So you tilt the first pendulum. By angle theta, length L. All masses are equal to n. So that's a good. Uh, so what is the height raised by the last ball? So find the height at which the nth ball will rise, or the angle by which the nth ball will tilt. Find the So it's very simple. What you can do is simple. So you know the what is the velocity of approach for the first two ball, and then this velocity of second ball will act as a approach for the third and so on. So it's very pretty easy. Can you do that? Oh, just wait, just wait. If I do so, then uh, yes, then you also need to conserve the momentum because masses are. This is the different problem because your masses are equal. So we cannot take the case that only definition of E will give you the answer. In fact, you need to also conserve the momentum. So yeah, this is a nice exercise to do this calculation. So you first conserve the first conserve or first apply for 1 and 2. Then write definition of E. Repeat at least 2 to 3 times for next pair of spheres. Find the mathematical pattern and solve. So you may try for some time, then I will solve. So anyone getting the answer?
No,
So first of all, if you release from rest, what is the speed with which it will hit the second ball? So the V is equal to how much? Under 2 GH. And what is H here?
L minus 1.
Okay. So now this is the V naught. It's called. So when V naught will hit the ball 2, so it is like a ball 1 is V naught, ball 2 is rest. And after collision, ball 1 will have some value that's called V1. And ball 2 will have some value that's called V. So write the conjunction on top. M V naught equals to. Oh, so the sum of velocity is V naught. That's equation 1. Now write the definition of E. Separation upon approach. And if you solve these two, what will you get? So just add, you get that's it. So if you hit, then it's not a big deal to find the third velocity. Because now 2 will go with V2 and will hit. So the V3 will be how much? So there is a pattern in this. So if you repeat similarly, the V3 will be, so V4 will be, so on. So Vn will be how much?
1 plus E by 2 Vn minus 1.
Now if you write the V2 value, which we have already got, this will make it square. And this will make it cube. And so by the same logic, this will be n minus 1 V naught. So the last ball will have Ke of nth ball just after collision is half m Vn square, and this must be equals to mgh dash, which is the new height raised by the last ball. It will rise by some value. This is 5, and the center mass of this two will rise by h dash. So we can write as 1 by 2 Vn square equals to g into h dash, which is again L into 1 minus cos phi. And now Vn square is how much? 1 plus e by 2 power n minus 1 into 2, because power gets multiplied, into V naught square is GL this becomes 1 minus e by 2 power one minus cos theta. So no, it's just a matter of time pass. You can say phi equals to cos inverse of this value. If I set theta is 60, then this is fairly nice expression. And then I can also tell that n is just a 10 or whatever. So this is your answer. So this is called sequence problem, and In books, you will get thousands of sequence problem. So very soon, I'm going to share a PDF for this particular chapter, which is referred normally. So all books are not so comprehensive in terms of variety of problems, which generally one should solve. So I will be sharing you with one particular set of questions, which is really challenging and really good. If you have solved Esurma, then you will have some basics now, and hopefully you will be able to attempt and solve. Okay, so we'll continue more of the problems which demands the conservation of the manure in the next lecture. So for today, let me end the lecture here. And I think, yeah, so this week classes are over. We'll meet in the next.